So today I am going to start chapter 7 mathematics class 10 session 8, and in this chapter we will study about this theorem 34, and in this theorem we have to prove that the front angle formed at the center of a circle by an arc is the double of the angle formed by the same arc at any point on the circle. So these are the figures, but before explaining this, I will discuss some other topics related to this. That is, what is the meaning of arc and other things. So just after some time, I will discuss this. So first, let us discuss the meaning of arc. What is the meaning of arc? So first, what is arc? If you draw a circle like this, so there is a center here, and when you draw a chord like this is the chord AB. Okay, this is the chord AB. Then in this chord, suppose this is the center O, and suppose there is any point Q here, and this is the point P here. So this chord divides this circle into two parts, that is the upper part and the lower part here. So this is called the segment. This whole figure is called the segment. That is, if you shade this, then this whole part is called the segment, and this is called the minor segment because this is smaller, and this whole part is called the major segment because this is bigger part. So this whole area from this point to this point, this whole thing, this is called the major segment, and this is called the minor segment. Next, here we discuss the arc. So what is arc here? So this that is the part of the circle. This is the whole circle here. So this whole is called the circumference. But when you take the part like this part here, so from this point to this point, we have this part here. So this part is called the arc. And again, there are two parts. That is, because of this chord, it divides this circumference into two parts here. That is, the one is this bigger part here, this and this is the smaller part here. So this smaller part is called the minor arc. You can write here APB. This is the style. This is the style of writing for this APB here, and AQB is called the major arc. That is AQB. This is the major arc, and this is the minor arc. So these are the 2 points here, and then you have other topic in this. That is, first understood, I think you understood this, that what is the meaning of the minor arc and the major arc, and segment, that is the major segment and the minor segment here. The next is that is the angle subtended. Like when we draw another circle, suppose I will draw another circle like this, and in this there is a center here. Then take any 2 points here like this. We have taken 2 points, then draw this here. So here this arc makes angle this at the center. You can say A, that is angle AOB at the center of the circle. That is because of this arc, that is, this arc is subtending angle AOB at the center. And if you take any part on the other part, that is the, suppose here this point Q here, and if you join this like this, then this is the angle subtended by the same arc in the alternate segment of the circle, because you can see here that if you draw this, then this is the segment here. So arc is here. Okay, this is the arc, and this arc belongs to the minor segment, and this point is in the major segment here. So that is why it is called the opposite segment here. So this arc subtends angle AOB at the center, and the same arc subtends angle AQB in the major segment. So these are the 2 points here. So you must remember this, and the theorem which I am going to discuss, you must remember this. That is the angle at the center and angle in the alternate segment. So these are the 2 points here. So Next, now I will discuss this theorem here. So now this theorem, in this theorem again, now see that here this arc, that is we have this arc here, this is the arc, so that is arc APB here, and this arc APB subtends angle AOB at the center, and the same arc subtends angle ACB at the alternate segment here. So in this we have 4 situations here. That is when APB is a minor segment, and when APB is a semicircle, because here this is the diameter, so this is a semicircle, and when this is the major arc, it may be major arc here, or this may be again like this, that is when the point C is here. So these are the 4 situations, and in all the 4 situations this is valid. That is angle AOB, angle, that is angle this is equal to twice of angle ACB. That is in all the 4 cases this formula will be valid. That is angle AOB is equal to 2 angle ACB. So here we will prove this. So we have to draw these 4 situations. First we will take this here, and in this situation, see that in the next page, here in this you can see the whole page, and in this whole page here first in all the 3 cases in triangle AOC, okay, you will see in this triangle AOC, that is this triangle here AOC. So in this triangle AOC extent here OA and OC are equal. Here OA and OC are equal because these are the radii of the circle, because these 2 are the radii of the same circle, so these 2 will be equal. So when these 2 will be equal, then their opposite angles will also be equal. That is this angle and this angle will be equal. This is the theorem, because in any triangle, if the 2 sides are equal, then their opposite angles are also equal. That is why these 2 angles are also equal. So now we will write this here. Here I have written here that OA equal to OC, and then angle AOC equal to angle OAC here. And next, in each case in triangle AOC, if CO is extended, that is this CO is extended to point D here, then in this case we have this angle. This is called the exterior angle, and this angle is equal to this angle plus this angle. Again, this is the theorem here. That is in any triangle the exterior angle is equal to the sum of interior opposite angles. That is why this angle is equal to this angle plus this angle. So here I have written this angle AOD equal to angle OAC plus angle OCA, and because angle OAC and OCA are equal, so we can write this OAC equal to OCA plus OCA. So it will be 2 OCA, that is OCA, that is this OCA plus OAC, or because these 2 are equal, that is why we will write here that angle AOD equal to 2 angle OCA, angle AOD equal to 2 angle OCA. So now we got this result, and we will do the same process in this triangle BOC also, and we will get the in this case we will get the result, that is angle BOD equal to 2 angle BCO. You will see here I have written everything, and in the same process you will get angle that is triangle BOC, and in this BOD equal to twice of angle OCB. The process is similar, okay, so there is no need to explain the same thing here. So here you will get angle BOD, angle BOD equal to angle 2 angle OCB here. So next here this is the equation number 2, this is the equation number 1 here. Now add these 2 equations, you will get angle AOD plus angle BOD. So angle AOD plus angle BOD is equal to twice angle OCA plus twice angle OCB. Now see the figure. Here this angle, that is angle AOD plus angle BOD, will be equal to what? Angle AOB here, and angle OCA plus OCB will be this whole angle here. So we will write here that angle AOD plus angle BOD, and then this is equal to angle AOB, and this is equal to angle ACB here. So angle AOB, that is angle this is equal to twice of angle ACB. So this is the proof here, that is angle this. In the next page here this. So, and this is true for, that is in this figure, that is in figure 1 and 2, angle AOD plus angle BOD this, then angle this. So this is the answer in this case. And for figure 3, what is the for figure 3 here? For figure 3, because this is here, this is the you can say that this angle is subtended by the major segment. So this angle is called the reflex angle. So here we will write that reflex angle AOB. Whenever we say reflex, means that we are talking about this angle, because whenever you have the, like suppose this is the angle here, then in this case when you say, suppose here PQR here, so angle, when you say angle PQR, then it means we are talking about this angle, not about this angle here. So whenever we say that is your PQR, then whenever you make an angle, then there are two angles always, because one is the smaller angle and other is bigger angle. But whenever we talk, then we are talking about the smaller part here. That's so here angle PQR. Whenever we say angle PQR, means this angle, not this angle. So for this angle, if you mean this angle, then you must say that this is the reflex angle PQR. So here also we mean this angle. So we will say that this is reflex angle AOB. That is why here I have written reflex angle AOB. So in this case, reflex angle AOB is equal to twice angle ACB for the third figure, for this third figure here. And for the fourth figure, here again, because here see that angle, this arc APB subtends angle AOB at the center, and there is a point C. This point C can be anywhere from this point to this point. That is why it is true for every point here. If this point C, you can see that this point can move from this to this, that is here to here, and in each case this result will be true. This result will hold true. So here also angle BOD, that is see here that angle BOD minus angle AOD, BOD minus angle AOD equal to 2 angle OCB minus 2 angle OCA. So in this case also you can see that you will get the same result here. So in all the cases the results are same. So so you must know how to prove this. This theorem is most important in this chapter, and remember the statement and also what is the theorem and how to prove it. So you must remember the theorem and how to prove it. And here I will show you first the whole page here. This is the first page, and the next page is this. You can see the whole page clearly, and this is the third page. So I hope you understood this whole theorem, and then I will discuss one or two questions here. For example, a simple question I will take. For example, take a question like this. We have a question. For example, this is the question here, and in this question we have this figure, and this angle is 110 degree, and the figure is like this, and this here joint. So this is B, A, C, and O, and in this figure we have to find the value of angle ABC. What is the value of angle ABC? We have to find. Now see that this is 110 degree, then we will find this angle. So what is this angle here? That is reflex angle. Reflex angle AOC will be equal to 360 minus 110 degree. That is 0, 5 and 2. So this angle is 250 degree here, and therefore you know, by this same theorem here, angle ABC, this angle will be equal to half of this, or the same thing, that is you can say that angle reflex angle AOC equal to twice angle ABC. So this is 250 degree is equal to 2 into angle ABC, and therefore angle ABC is equal to 250 by 2, that is 125 degree. So the answer of this angle will be equal to 125 degree. So this is how we will solve the questions in this chapter. So then you will also solve the chapter in this exercise 7.1, and most of the questions, all the questions are based on this theorem. Okay, so you will solve it. So I have explained you all these things. I hope you understood this. Thank you for this.